Kernel trick. Kernel trick. Okay, guys. So this is what is quickly about and what is the hyperparameters you are having in SVM? C क्या होता है? क्यों बोला? हाँ क्या हुआ? शुभम आप ही हो ना? कुछ भी रिएक्शन नहीं है. What is C? What is used for? C is used for control error. Which one you will be using the C with? What is gamma? Curvature. So which one you are going to use that gamma with which kernel? मैंने कल बताया था RBF. RBF deals with the non-linearly separable data. In that, your curve will be in a curvature. There you will use the gamma. And when there is a linear is there you will use the C. And what is the one more hyperparameter? एक तो C है, दूसरा गामा और एक टॉलरेंस और iteration, maximum iteration, or kernel itself. Kernel itself is a hyperparameter where you can give the different values. Okay, guys. Now this is what is all about your. If you go in an interview with machine learning, they will definitely ask you the question with the SVM. Remember that, and decision tree. These two are very important ones. The remaining all. Maybe NIBase, you may get the questions, you may not get the questions, but these two, they will definitely ask because based on this only, your ensemble learning is completely based on. Okay, now let's go with the next one called as decision tree, guys. Now, decision tree is again, it's a very easy, but at the same time, it is very powerful algorithm. Okay, decision tree. Now, decision tree, as individually, you will not use it. Now, all these individual algorithms are there. What are the individual algorithms? We have seen the linear, we have seen the logistic, we have seen the decision tree, SVM, and KNN. All these things are individual algorithms. They are not powerful. They are individually, they are not powerful. NIBase, it's okay. But remaining all are individually, they are not powerful at all. They are called as, they are the weak algorithms. They are called as weak algorithms. These weak learners, we are going to combine together to make it a strong learner. We will combine together. Like if there is one stick is there, it is weak, you can break it. If you have the bundle of the sticks, what will happen? It will become very strong. The same way, if you take it a one decision tree, it is very weak. It will not give you it is not a perfect algorithm to implement on the solution. So in order to implement that, you have to get the real power of the decision tree. You have to use the multiple decision trees together. Using the multiple decision trees together is called as random forest. Okay, multiple decision trees when you are using together, that is called as random forest. This is the concept of ensemble learning. Ensemble learning is nothing but you are going to club up the weak learners together to make it a strong learner. Now in that, you will use that 10 decision trees, 50 decision trees, 100 decision trees together also. It depends like which one you want to do. Okay. Now the question is, what is a decision tree? Now, see, decision tree again, it is a supervised algorithm, guys. Supervised algorithm, which is specially used for classification. But this is also having a power to use it for the, regression also. But this is a weak regressor, but very strong classifier. Okay, very strong classifier. Now, if you are going to take it, see, one more important thing is, now linear regression, it is having its own formula, right? Logistic regression, it is having its own formula. KNN, it is having its own formula. Decision tree as an individual, it will not have its own formula. It is having a sub-algorithms. And using that sub-algorithms, they will use it. Okay? So two major sub-algorithms are there. One is Gini and the impurity finding is called as Gini and the entropy. So when you are using the decision tree with the Gini, they call it as CART algorithm, C-A-R-T. When you are using the decision tree with the entropy, they call it as ID3 algorithm. Okay, so don't get confused. Decision tree is based on the sub-algorithms called as CART and ID3. So CART is when you are using the Gini as an impurity finder, then it is a CART algorithm. When you use the entropy as an impurity finder, then it is called as ID3. Okay, don't get confused. Okay, now just I'm giving you because we are going to use these terminologies a lot and lot and lot. Okay, first, this is a process of dividing the data set into different clusters or the groups by adding the labels. Okay, this is a classification. Now, the best way to find the decision trees over here, guys. Decision tree is a tree-based supervised algorithm, okay, which splits the data into subcategories. There is a big data will be there that is splitted into subcategories based on a condition. You will be having a condition. Based on the condition, you are going to split the data. And this you split, you will be having this homogeneity of the data. So you will be having the like same type of data will be there. Okay. And this splitting is done with the help of sub algorithm based on the condition, and these sub algorithms I told you just now. What is this? So usually the decision tree will be based on the sub algorithms. They are the CART and ID3. So these CART and ID3 are the ones which are going to use it to split the data. Okay. So when you take it from the starting, classification is a process of dividing the data into two categories. And it is a two-step process, guys. Learning step is learning data from the data. Second one is prediction. So this is an easiest and popular classification, very, very popular classification algorithm, one of the best algorithms. And how to define it? Decision tree is a tree-based supervised algorithm which splits the data into subcategories or nodes, subcategories by increasing the homogeneity of the data. And this splitting is done with the help of multiple sub-algorithms based on the condition. Okay. Now, this is applied on the both. One is the categorical data and continuous variable. Okay. This is called as decision classifier, and this is called as decision regressor. Okay, it can be applied on the both, but it is a weak, very weak regressor, but it is a very, very strong classifier. Now, if you take it, a simple example, how a decision tree is working. See, simply the decision tree will be working on the if-else condition base. Simple. Now, if you take it, a simple example, now you will be calling the customer care all the time, right? So immediately if you call a bank, suppose a bank customer, HDFC, first thing what happens? No girl will lift. Automatically there will be an auto answering system will come over there. It will ask, okay, you are an existing customer or non-existing customer. You will say that, no, I am an existing customer. Then it will ask the next question. What is that? You are looking for that, you are looking for that some account problem or the credit card. Yeah, I say credit card means it will go to the credit card. And it will say that, okay, you are wanted to apply for the credit card or you are existing. Then you will say, yeah, I'm an existing or I want to apply. If you want to apply, it will take it to different. And if you are existing, it will take it to different. What is happening over here? If and else. If you are an existing customer or not. If it is existing customer, it will do some. If it is not, it will do some. Right? How it is going on? If else, if else, if else. The same process the decision tree will go on. It will apply the if else mechanism. Now, if you take a simple example over here, see there are some gender is there over here and education and suggestions. So if he is a student, obviously they will be paying a lot. Okay. Now, if he is a programmer, like a professional, he will be spending more time on the GitHub or WhatsApp. Just take it. Now, if a new person comes, I want to suggest what apps I want to do. First, let's do it in this case. Okay? Let me take this one, 2 hours. Now I'm going to put down over here. This is the data, guys. I have it. Now I want to वो क्या होता है ठीक है वॉइस आ रहा है सही दोनों आ रहा है सही रिकॉर्डिंग कर रहे हो ना नहीं आ रहा आ रहा है now guys let's see this here I want now there are 2 ways I can split it up. Understand this one. First one is I'll be doing with the student. Okay, I'm doing with the occupation I'm doing it. I'm splitting based on the occupation over here. Okay, when I apply the occupation over here, first I have the 2 options over here. What are the 2? Student and programmer. Now when it is a student, what are the comes over here? PUBG. And if it is an occupation, guys, then again I'm having a mixed stuff over here. What is that? GitHub and WhatsApp. Okay, WhatsApp. Now again in this, if you check it out, GitHub and WhatsApp in the programmer over here, if you check it out over here, all the programmers, there are males and females are there. Okay. So again, you can split it on the male and female over here. Based on that, you can do it. Now the second way is I will go with the gender. Now I will split it based on the gender over here. Okay. Here I will give it as gender. When I give it as gender, I will have the male and female. If it is a male, now males, you can see this, 2 students are there and 1 programmer. So you will be having both professionals and students. And in this also, you will be having students and professionals. Now again, based on the occupation, I will divide it over here. If it is a student and it is a professional. If it is a student, they will use the PUBG. And if it is a professional, they will use mail. Which one they are using? WhatsApp. Okay. And in this case, again, further dividing it, I will use it student, female student. Obviously, which one it is? PUBG. And female programmer in GitHub. Now you see this. Previously, when I split it with the gender, I'm getting the professionals and students, and here professionals and the students. There is an splitting is there. If it is a male, it has to go to this one. If it is a female, it has to get to this one. If it is again a student, it has to go over here. If it is a professional, it has to go over here. The same thing is happening. This is nothing but if gender is equals to female, then what it has to do? It has to have one more if condition over here. If occupation is equals to student, then I will give it as PUBG. Else, GitHub. And this one will have a else over here. Else, again, if condition will come down here, and occupation is equals to student PUBG. Okay. Else we are going to write it as WhatsApp. Right? What is this? This is nothing but an if else. Based on this only, your entire decision tree is based on this. Based on your entire decision. Now the question is, which one is correct? Either going with the occupation is correct or going with the gender is correct. So this is very small, you can do it. But this is the actual thing you have to find out in the decision tree. Which one is the correct way to go forward? Okay. Now, if you take it out over here, now here you see occupation, I'm keeping it as student. Directly I'm giving a student. Then all the students are going with the PUBG. Right? So is there anything else over here? Only students all are pure. They are PUBG. Else, again, I have to look for the gender. This else means again they are the professionals. Gender is female. And that is else WhatsApp. Now this is the way you will be doing it. Now you can form up tree over here. Can you see it? If it is an occupation, then all the PUBGs are coming up. If it is no, as students are occupation is not student, then we will be going with gender again. Gender, I'm dividing it to the GitHub and WhatsApp. Okay, based on this only, purely based on this one, it is going on. Based on this, we are doing it. So it purely depends upon your if-else condition. Nothing else but your if-else condition. You see this? Now, if it is a student first, then this is the one. There are two options will be there. If it is true, PUBG. If it is true, it is PUBG. Else, it is comes again. There is an if condition. Again, it will go to the gender. Like if it is a female, then GitHub. If it is a male, then it is a WhatsApp. Simple. This is the way you will be doing it. Clear, guys? This is a basic structure of your decision tree. It is purely based on your if and else structure. Okay, guys? Now, if you take it like usually what happens is divided in this way. Usually. Now, suppose I'm going to give it a simple structure. I will take it over here. Now here I'm having okay. Now I'm having some data with me. All circles I'm taking it over here. Okay. These are all the circles. And I'm having as triangles. And I'm having a squares over here. Something like this. Triangles and squares. Okay. All are triangles over here. Now, first split. I want to make it over here like this. I want to make it on the circles. If the shape is circle, then I will get the circles over here. Now I will do the first split over here like this. Okay. Now when I do it, I'm getting all the circles, guys. Yes. Now second split, that is one part I'm having pure data, and second time it is an mixed up data. It is not a pure one, right? So in this again, I will do a split. Okay. What split I will do it? Right? Then I will get a pure form of this, and then I will say that this is a pure form. Now this one, how I will write it is, if just take it a simple way, I will say that first point over here, if it is a circle, true means this side. If it is not a circle, I should go this side. How many I am having? Circles I am having, triangles I am having, and squares I am having. If it is circle is yes, and if it is circle is no, only two. If all the circles are there, I'm going to take it over here. Maybe all the circles will be coming up over here. Okay. Now, in this case, all non-circles will be coming. What are the non-circles? Triangles and squares. Now, this is the pure form. Is there any need to again split it? No need to split it over here. Now, this one, yes. On what basis you will split it? If it is a triangle and if it is a triangle or not a triangle, that's it. The condition will be something like this. It is a triangle or not a triangle. If or else. Okay. If you can keep it a condition. Else you will have a condition. No. Whatever the non-satisfying will be coming over here. So this one will be triangle. Yes. And triangle. No. You can keep it square also. That's not a problem. Here what you are going to get it? All triangles over here. Okay guys. Now here. Maybe I have the squares and some dots also. Just take it. Dots. Here also I am having some dots. Just keep it small. And here I am having a dot. Now 4 or 5 dots and squares. Now this one, can I do it? No. This is a pure form. There is nothing else is there except then triangles. In this case, again you have to split it. Based on what? Squares or not a square. You keep it as square, yes and no. If it is square, I will come down all the squares over here. All the squares will be there with me. Okay. If it is not a square, you will get it all, whatever it may be. It may be dot or anything will be coming down over here. This is nothing but your decision. Clear guys? Okay. This is the way your decision tree will be working. Simple. If and else. If and else. That's it. And whenever you want to talk about geometrical intuition, whenever you are trying to split it a decision tree based on a purity on condition, what will happen is always each and every line, whenever I split it up, that will be either parallel to the x-axis or y-axis. Remember that. Either it will be parallel to the x-axis or y-axis. Now, in this case, you take it over here. My whole data is there. Now, I have a picture over here. Let me take it. Now, here, let me do this. This is a picture. Now, just take it. This all is the circles. Now, these all are maybe squares. Okay, these all are squares. Okay, guys. Now, these all are maybe dots. Take it as dots or maybe some triangles. Okay, let me take it as triangles. Okay, and these I will make it as okay. Any shape? Circle या now rectangle. अच्छा ठीक है, rectangle ले लेते हैं. वो भी square ही है. उससे क्या? पहले बोलना था rectangle लेना, तो वो ऊपर का square बना देता था. Now this is a rectangle. Okay. Take it, guys. This is my entire data. Now, first question is, what is that? Is it a circle or not? So I'm drawing a line. Is it circle? Yes and no. If it is yes, all the circles will be coming over here. Got it? All the circles will be coming over here. If it is no, then what you are going to get it, guys? You will get it completely. Whatever are non-circles will be coming over here. Okay, all non-circles will be coming over here. Now, this is pure form. This is yes. Okay, we got it. Now, in this case, again, I have a lot of impurity. I have a square, rectangle, and a triangle. Now, I will take it. Which one I want to take? Triangle. All triangles are downside. Yes. And non-triangles are upside. Okay. Now, when I did the first split, when it is a circle, either it is a circle or non-circle, see that this line is parallel to y-axis. Now, when I'm checking it out with this one, that is whether it is a triangle or not, sorry, rectangle or not, I'm getting a line which is parallel to x-axis. Now, next after this, there is a impurity over here, right? Now, I will draw a line whether it is a square or not. When it is a square, this side, yes. Non-square, this side, no. Okay. When there is a square is there, this side will be there. Non-square, all will be coming over. Now, again, see the line. Line is parallel to y-axis. So, whenever you are doing a geometric intuition of the decision tree based on the lines, whenever you split it, either the line will be parallel to the x-axis or y-axis. That's for sure. Okay, that is a point you have to remember. Now, hope you got it, the basic understanding of your decision tree. So, decision tree is a tree-based algorithm which is based on the condition. If the condition is true and false, that's it. If you give a condition, if it is true or false. But the real question is, which one will be your first condition? Now, here, where is that? Here we have taken it. Which one I took it? First condition is square. Sorry, circle. Right? First I took it as circle over here. Now, based on this, I took the circle and then non-circles. Then I took the, triangle over here. Triangle. Again a condition triangle. And this. Now the question is, why can't the triangle can be over here? हाँ ठीक है, ये सर्कल दिख रहा है. हाँ, कुछ और डेटा ले लो. उसका क्या है? सोनार का डेटा ले लो. क्या होगा? So that is a big question. Which one is the right split? You have to do it over here. Before that, let's try it out the terminologies over here. That is done with the help of Gini and entropy. Gini and entropy. Before that, you have to understand what is the impurity first of all. Okay. Now, let's see the terminology, guys, over here. Now, first important thing you have to understand is whenever you are dealing a decision tree. Okay, decision tree is a tree where each node represents a feature. That's for sure. Each and every node is nothing but this part. This part is a node. This node tells us the feature over here. I'll tell you what is a node, not a problem. As of now, you take it. And decision, and each leaf node represents the outcome. What is a leaf node? I'm going to explain you just now. Now, this you ignore it. Now see this one. Okay, this is a tree. This is a tree. Now you see this, that first the tree is split based on different conditions. Now let's see that what is the root node over here. The first node will be there, right? First split we are going to make it. That is called as root node. Okay, that is called as root node. And after splitting, I'm going to get it two outputs. I got yes or no. Yes or no. And when it is yes, again, if there is an impurity inside that, that is, you see this, yes and minus are there, splitting it up based on some condition. Here I got a lot of yes and minus. Here I got a lot of minus and yes. Right? Is that pure form? What is the impurity over there? Yeah, see this. This side, the minus is the impurity, and this side, yes is the impurity. Actually, this side, yes is the pure form. When it is changing the position, it became an impurity over there. Now, this one I will further divide into two splits. Now this is a node. This is a node, right? This is divided. This is splitting. This process of splitting the root node or any node based on a condition, that is called as splitting, guys. This is called as splitting. These lines which are going on is called as splitting. And then we are getting a subnodes. These are subnodes. If you check it out here, where is this? Now let me see this. This one is the root node. Okay, this is the root node, and we are splitting based on a condition over here. This is the splitting process of splitting, we will call it, based on the condition when we split the data, that is called a splitting process. And then we got it, this one, right? And this one. These are coming out of this node. So they are called as subnodes. It's showing us something else. Subnodes. Okay, they are called as subnodes. These two are subnodes. And these subnodes are further divided over here based on a condition. Then this will become a decision node. Okay, this is a root node, right? This is a root node. Now, when the root node is splitted up, then it will become a subnode. And when the subnodes are further divided, then this will become a decision node. Okay, guys, decision node over here. Then out of this, you are going to get the some more subnodes over here. Now, just check it out over here. This is having any impurity. This one is having any impurity. This one be further splitted. This one, the where you can't split it any further, that is called as leaf node. Leaf node or terminal node. Okay. First is root node. Root node will be splitted into subnodes, and these subnodes are further splitted. Then this subnode, first one is called as a decision node, and these are again the subnodes. And looking at their purity, if these subnodes are further not divided, then that will become a leaf node. Okay, guys, leaf node. Now, if you see this one, you will get it. Now, this completely is called as a subtree also. This completely is a small part is there. It's called as subtree also. So let me show you. This is a root node. Now, this is a process of splitting. You see this? Splitting is a process of dividing the node into two or more subnodes. Okay? Now, next one is decision node. When subnodes are further divided into more subnodes, that is, more subnodes, the initial subnode is called as a decision node. In this case, this one will be the decision. Actually, this is a subnode from here, root node. When that subnode is further divided, then that is called as a decision node. And whenever the subnodes cannot divide any further, that will become a leaf node or terminal node. Nodes which don't split any further is called as a leaf node. These all are leaf nodes. This is not a leaf node. You can further divide it. This is a leaf node and this is a leaf node. This can be further divided. Okay. Now, next one is here subtree. When you take it about the subtree over here, see again, this complete part is called as a subtree. There is a one decision node, and you call it as one decision node with the child nodes is called as a subtree. And again, this is a parent node also you can call. Now, the things what you have to remember over here is most important is root node, decision node, and leaf node. This is the one which you have to remember the most. Let me show you. Now here you can see it. This is a root node. This is a decision node. This is a splitting. And this part is called as a branch or the subtree. Where there is a decision node and subnodes are there. That is called as a subtree. Now, where these are the terminal node, which are also called as leaf nodes over here. Clear, guys? Now, when you go back to the earlier slides over here, now you know what is a node and what is a, now here you see. Decision tree is a tree where each node, now you know that each node after splitting up, that represents one particular column. Remember that each node will represent a particular column. Okay? Now that is a feature, each represents a feature, each link represents a decision. Now, each link represents a decision. Again, this will be a link, guys, which is splitting. We are doing the splitting, this is called as a decision, and each leaf node represents the outcome. Now, this is whatever the last outcome is there, right? Leaf node, terminal node, whatever you call it as here, terminal node, or this is nothing but the final outcome. Okay, guys? So, this is a basic structure of your decision tree. Now, this is okay, we can talk about that one later. Now, the most important thing is pruning. What is pruning? See, pruning is a process where you cut the tree from further growing. When you cut off the tree from further growing is called as a pruning. Okay? Pruning. That is what is called as pruning. That is, see, if you have a decision tree over here, just see this. I have a decision tree. I will start from here. It is splitted. Okay. Now it is further splitted. Okay. And then it is further splitted. Now this is the A splitted to B and C. And this is further splitted to D and E. And then this is further splitted to F and G, something like this, F and G. And this is also further splitted, like you can go ahead and take it E1, E2 or something like that. And this is also further splitted. And this is going on, guys. This is going on. So what happens is after a given point, this completely, it will split up each and every feature of your data. When it is splitting each and every feature of your data until and it reaches a leaf node for all of them. Then what happens? This tree will be going deeper and deeper and deeper down. When it go more deeper, then it will happen. It will read more and more from the data. When it reads more and more from the data, what will happen? Overfitting will happen. Clear? Now, then, okay, you may say that, okay, that is a problem is there. So I will stop it over here only. Then in that case, your model will not learn from the data. Then in this case, what is the problem? Underfitting. So if you are allowing it to grow through a full of its length, it will be a problem of overfitting. And if you are not allowing it to grow through the full of the length, it will be a problem of underfitting. So what you are doing is you are taking an optimal space, optimal place, and then you will stop this tree from growing any further. Okay. And this, the stopping point, is called as a maximum distance from the root node. Now this is, if I am stopping over here, then this will be, my maximum distance will be 2 nodes. Maximum distance will be 2. Now I will stop it over here, then it will become 3. This will be 1, 2, and 3. So the maximum distance is nothing but the distance between the root node to the leaf node, whatever you are allowing it to split it, that is called as the maximum distance. This is the very important hyperparameter of the decision tree, which helps us from not allowing us to go any further. Clear? So this is the way you will be stopping this process of stopping, cutting off the tree. That is called as pruning. Pruning is nothing but, again, there's a cost complexity pruning and reduce error pruning. This is not much. So the thing what you have to know over here is, okay, we will talk about this one. There are 4 major algorithms will be supporting sub-algorithms to the decision tree. One is the ID3. Okay. Second one is called as C4.5. This is nothing but a successor, which is an advancement of the ID3. Okay. Then there is a CART algorithm. In this, we are going to see the ID3 and CART. That's it. Now these two we are not going to touch it. One is the chi-square and the successor of ID3. Now I told you just now, what is ID3 algorithm? When the impurity, the finding mechanism is entropy, and CART is Gini is the clear. Now what is the entropy? Now here it is. It is CART is there. Gini index, now that is Gini only. Gini is the impurity finding mechanism. Otherwise, it is an entropy, guys. Now let's see this. What is this Gini and what is the entropy? Okay, what is actually the Gini and what is the entropy? This is nothing but entropy allows us. It is used to find out the randomness inside the data. Okay, Gini indicates the impurity of the data. Now, what is the difference, guys? Is the difference? What is the randomness and what is the impurity? See, both are same. Now, if you take it simple, just try to understand this. There is a box is there over here like this, and inside this you kept it all squares. All the squares you kept it inside this. This is a square. Okay. Now this is completely closed. This box is completely closed. You can't see anything inside this. So now you have a chance to put your hand and remove the one object from this. Now, what is the chance of getting the square? What is the chance of getting the square if you remove one object? One means what? 100%. That is 100% is the chance of getting the square, right? Now, see this. In this, now I will keep it some circles over here. Some circles. Now, what is the chance of getting me? Is it 100%? Why? So there is a circles is also there. So what is there? That is called as randomness. So there is a randomness inside. That is called as randomness. So this randomness, we can find it with the help of entropy. Entropy is the one we are going to use. The same thing, the term is same. The randomness is that when you are getting when you are picking up the data, when you are picking up an object, you are randomly getting it. There is no particular mechanism. You may get the square or you may get a circle over there. This is called as randomness. When there is a randomness is there in the data, that randomness can be calculated by using the entropy. Entropy is a process of calculating the randomness in the data. Okay. Now there is something called as impurity. Now the impurity is again the randomness only, but here if you take it, just now we have seen it. I am having some grains with me, like say that I am having rice over here. Okay. In this, the stones are there. Then what is that? That is an impurity. Stones are impurity in the rice. But you know, there are something called dal is there inside. Dal is there. Is that dal is relevant to the rice? It is relevant to rice. Is it rice? No. So this is also considered as an impurity. This is nothing but the randomness only, but this is impurity. We consider this as impurity. You will remove it and throw it off. Remove it and throw it off. But at the same time, you are having another vessel. You are having all dal inside this. And inside this, there is some rice. What is that? Is that impurity, rice or not? Yes. See the situation over here. When the rice, inside rice, there is a dal. That is, dal is the impurity. In this case, which one is impurity? The rice is impurity. Based on the situation, actually the definition of the impurity changes. This impurity, we will find it with the help of Gini. Gini index is the one which we are going to find. Now, why we are going to learn this? Why we are talking about this? So, when we split the data, when the first split, when we are doing it, now I'm having, I told you over here in a scenario, we are splitting, where is that? Here. We are splitting data based on the squares, based on the triangles. First, I did it with the circles. Then I have done it with the angles. Then I've done it with the squares. Now, why can't I do my first split based on the square triangles? I want to say that triangles, yes. So I will get the triangles over here. And non-triangles I will get. Why I'm going with the circles? What make us to do that? So this is a very simple mechanism, but when there's a lot of columns are there, you will be in a dilemma situation that which column you have to use it for your root node. Root node from where you have to split it. Now, for example, another one is if you are having a bowl of fruits are there, guys, here. You are having oranges, you are having apples, you are having the grapes, okay? And you are having the bananas. Take it, all the bananas are there. Now, I want to split the data. Okay. Now, I have multiple options to split the data. Now, maybe this is not, and I will take it as a watermelon. Now, multiple options are there to split it. What is that? Now, based on the weight, what is the color? Let's take it as a color. Based on the color, I can split it. Second one is based on the shape, I can split it. Or based on the weight, weight, I can split it. Now, which one I have to go with first? Which one? Now, this is a shape, this is a color, and this is a weight. Now, this is where you will be using the entropy and the Gini. After splitting it, when the randomness is, whichever the split which you are doing it, when the randomness is low, that is, when the randomness is low, reduced drastically, then that is the one we are going to go with. Okay? When I split it, after splitting up, when the randomness is reduced drastically, then that is the one we are going to do. But how to calculate the randomness? Using the Gini or entropy. Okay, these two are used to find out the impurities only. That's it. The purpose of them is to find out the impurity. Okay, guys. Now you know what is the decision tree. It is a tree-based algorithm which is used to split based on a particular condition, right? And you know, this is purely based on a if-else part. Okay. Now, when you take it, like when there are multiple options are there with you, then we are going to go with that. We are going to find out the Gini or entropy to find out the best, which is the best one to split it at the root node. Okay. Now, this, again, there is a formulas will be there. Now, there are different terminologies are there, guys. The root node is the starting one, and then will be divides into the subnode. And when the subnode are further divided, that is called as decision node. And you know, if they are further divided and there is no randomness, there is a pure form, which cannot be further divided. That is called as a leaf node. All these things are pretty important, guys. Now let's go to the Gini, how to calculate the Gini. Okay. Now, see, Gini index is used to find the impurity in a large data set. Formula is 1 minus summation of Pi whole square. Okay, this is a probability. Pi is nothing but a probability. Now let's see that how we will be calculating. See again, which one you will be doing it is whichever the impurity is less. Remember that whenever I split it up, when after splitting up, when the impurity is less, that is what we are going to go with. Now, so first one is node split is decided based on the Gini impurity. Now we are going to decide it based on this formula. This is the formula. We are going to use it to decide the node split. This is a root node split. The lower the Gini impurity, the higher the homogeneity of the data. That is, more randomness is very less and more pure form it is. The less Gini is, the higher the works only for the categorical data and only performed for the binary. All of them are performed for the binary splitting. So let's take three categories, guys, over here. First one is all ones are there. Okay. Second category is all. Here, let me take it. We are having three types of data is there, guys, over here. One is all ones are there. Three sets of data. First one is all ones. Is there any impurity in this? Zero. In this case, how many are there? So how many types of data is there? Two types of data is there, right? Two types of data. What are the two types? One is 1 and second one is 2. So how many ones are there? 4. How many 2s are there? 1. In this case, complete randomness is there. Complete randomness. All of them are different. Now let's calculate the Gini impurity for them. Okay. Now let's take it. First, I will calculate the probability for them. For this, how many are there? Number of unique elements are 1. First set. Set 1. This is the first set. How many are there? Unique elements are 1. And what is the count of them? Unique element 5. So it will be total like 5 by 5 is equals to 1 is the probability. Clear, guys? So total number of count is equals to 5. 5 unique elements divided by total number of elements. That is nothing but 1 we are going to get. Now number of elements are 1. The probability is 1. So if you put it on in the formula over here, can you check it out? That is 1 minus summation is only 1 is there. So I will use it 1 square. You are going to get it 0 over here. 1 minus 1 is 0. So impurity is what? 0. The impurity is 0. So definitely because there is no impurity at all inside this. So how many unique values? 1. How many are there? 5 are there. What is the total number of elements? 5 are there. Number of unique values divided by total number of elements is equals to 1. Unique values are 1. Probability of them is 1. So you have 1 minus 1 whole square is equal to 0. Now in this, let's take the second category. How many are there elements? 2. One element is 1 is 4 and 2 is 1. So let's calculate the probability. 4 divided by total number of elements and 1 divided by total number of elements. So first one probability is given probability is 4 by 5. Second one probability is 1 by 5. Right? Total number of elements is 2. Now apply this one. Okay. 1 minus, here I am doing the summation. Give it in this way also. Don't get confused. Now you can give it as 1 minus, what is that? 4 by 5 whole square plus 1 by 5 whole square. Now this is outside, minus is outside. You can do it like this also. What this guy did is inside 1 minus 4 by 5 whole square plus minus 1 by 5 whole square. This is what you are doing. Okay. Now when you calculate this one, 1 minus 4 by 5 whole square and 1 you got it. Minus 32, 0.32. Now previous case is 0. Now what is that? 0.32. Which one is greater? Which one is greater value? Which value is greater value? 0.32. That is, impurity is more inside. You can check it out also. Here, there is all ones are there. Here, two are there. Two random values are there. So definitely the impurity is there inside. Now let's take the third category. See here, 1, 2, 3, 4, 5, like 1, 2, 4, 6, 7. How many different elements are there? Values are there? 5. And what are the unique values are count is 1, 1, 1, and 1. All the unique value count is 1, 1, 1. Now, it will be 1 by 5, 1 by 5, 1 by 5, and 1 by 5, 1 by 5. Now we have to add them. Okay, just it outside, you add them, you will get 0.8. So which one is having the impurity more? 0. Is more. So this is the mechanism you are going to apply to find out the impurity in the data. Now, whichever one is having the less impurity, that will be the first column to use it, the node, the root node. Okay, guys? So this is the way you will be finding. Now, this is a more effective way. This is a default one which you'll use it for the decision tree. When you are going to create a decision tree object, Gini impurity is a default one. Now entropy you want it means you have to change it. Estimator, you have to change the estimator, then only you will get it. Okay, guys? Now this is what here you see. Set 1 is the lowest, set 2 is the medium, set 3 is the highest. So here the lowest is the one we are going to consider. Now let's see the entropy and information gain. Entropy is nothing but measure of randomness. The term is different, but they will be doing the same. And what is the information gain? See, information gain is nothing but you are doing the first split. After doing the first split, before the, now this one what we are doing? We are calculating the impurity, first impurity, and we are giving which one is having less, you are giving at the root node. Okay? In the same way here also in the entropy, we are going to calculate the randomness, and which one is less, we are going to keep it at the root node. After splitting, randomness will be increased or decreased? Definitely it will be decreased. This decrease of randomness is calculated with the information. The decrease of the randomness is calculated by the information. How much the randomness is reduced is calculated by that. Now here if you take an example, guys, now this is having the apples and the labels. When you are going to pick both of them, all the times they will get the same apple and the. Now in this case, obviously there is an impurity is there. You will not get the same things, the labels and this one. Now you can define it something like that. In machine learning, entropy is quantitative measure of the randomness of the information being processed. Now here, what is the impurity over here? 0. So it is low entropy. In this case, this is a very high entropy over here. Now entropy is calculated with the formula minus pi log 2 of pi. Now log 2 is, again, there is a 3 types of logs will be there. One is a natural log, log 10 and log 2. So here you have to use the log 2 over here, or you can go with the natural log also, but mostly you have to. Now again, the number of classes and is the probability of each class. You can check it out how you have to do it. If there is an yes and no is there, there's 2 possibilities are there, the outputs. Now I'm going to find out summation of minus pi. There is nothing but how many are there here? Only 2 are there. So first I will take it as P of S. P of S log 2 of P of S. So this is the first category. Okay. Then this is the, because this is a summation, guys. This is the summation means you are going to add it. So how many possible outputs are there? Yes and no. When there is a yes is there, then you will be getting it first one. There is no is there, second one. If there are three are there, four are there, then how many times you will get it? 4 times and 3 times. Now, if it is a yes, you will be doing it yes. No, you will be doing it no. Okay. Now, there is an, here you take it. How many yeses are there here? 2 yes. Now, how many no's are there? 3 no's. And here, okay, 4 yes, 4 no's and 1 yes. Now, if you want to calculate the entropy, you can see this. So P of yes, log of 2, P of y, P of y, log 2 of Py. This is a yes one. And this is a no one. So what is the probability of yes is 2 of 5 minus 2 of 5. Log of 2, 2 by 5. This log of, again, you have to calculate it, guys. When you do this, you are going to get it 0.97. You want to do that? Or you will write log 2. You have the log 2 in this. Get log 2. Scientific you will be having? Sure. आगे नहीं दिख रहा मुझे. ये लॉग 10 है, ये लॉ नेचुरल लॉग है, लॉग 2 कहाँ है? Again we have to calculate this log 2 base 10 वो पूरा झंझट रहता है. Now let me see this one. If I find anything log 2 ఆగే ఇస్తారుగా ఒకడు ఆల్రెడీ ఉంది. You will get it directly log 2, guys. Now here, see this. I get that one. Minus 2 by 5 log 2 by 5, right? Next one is minus 3 by 5 log 2 3 by 5. Minus 3 by 5, right? 3 by 5. Okay. 3 by 5. 0 point minus 0 is 2 here, minus 0.732. This one is minus 0.732. And 3 by 5 कितना है? कैलकुलेट करो. सब में करो तो कैसा? 5. This 3 by 5 and 2 by 5. Minus 1 point. Okay. Okay. Minus 2 by 5. 0.6. And this one? 0.4. 0.6. This one is multiply G. You will get plus and plus, right? Total you should get is 0.97. आ गया? Okay, 0.5 into minus 1.3. This total is 0.5. Okay, this one is 0.5. I think 0.47 వస్తుంది చూడు. 52 అది 44 రౌండ్ ఫిగర్ చేసుకో, నాకు కావాలి కదా. 9.7. Yeah, got it. And 0. Natural log mat karo. Guys, now this is the way you will be doing it. Now, if there is, like here, you see this, if there is no randomness, when you calculate it, you will get it as 0. Okay? Entropy is 0. Now, this can be, now here there are 3 options are there, yes, no, and maybe. 3 are there, yes, no, and maybe. So when you calculate it, this one, you see, first one is yes, probability of yes, then probability of no, and then probability of maybe. When you do this, automatically you're going to get it yes. So when there is 3 values or 2 values, you can do it like this. Okay. Again, this all is for your information sake. Now questions may be, what is entropy? What is the information gain? What is the Gini impurity? What are the different nodes? Okay. Now the most important thing is how to stop the overfitting. So this is information gain. You see the formula over here. The information gain is E of parent, entropy of complete parent, which is before the root node. After that, of the child node. After splitting it, you will get the child nodes, right? That entropy of the child nodes, it is right. Okay. This information gain is total. Now here we have a root node over here. Where is the root node? Here. Now here I am having a root node, guys. Now, how to find out the information gain is you are going to find out the entropy E of parent. This is a parent root node, right? Then these are the children. So you are going to calculate the entropy of child 1 and entropy of child 2. And then when you are going to add these two and subtract it, now E of parent minus E of child 1 plus E of child 2. This is whatever you are going to get the subtraction. That is the decrease in the, randomness. This is called as information gain. Whenever there is an impurity is there. Now, obviously, here may be some impurity like maybe 1 point or maybe 10 is the impurity over here. After doing this, the impurity may reduce to 5. So what is the entropy? 5 into the entropy. So the degree at which the randomness is reduced is calculated by using the information gain, guys. Remember that. Okay. Now weighted is nothing but you are going to calculate the probability over there. Now this is a common, very, very commonly used example to understand the decision tree. You will be finding everywhere. This is a very commonly used. This is like, based on the temperature, the person is going to play the tennis or not. That is what it is being. Now, if it is the outlook is nothing but daytime temperature humidity and windy, then whether the person will play the tennis or not. In this, when I calculate the probability of playing the tennis is nothing but it is the actual parent entropy. I'm going to calculate the entropy, means this is nothing but the parent entropy. Okay, total after the outcome, that is a parent. Now after that, I'm calculating each child entropy over here. First one is in the outlook. I'm taking it as outlook. Can you see this? The outlook. The outlook in the previous, I'm having first one is sunny, overcast, and rainy. The three values are there. First, I'm taking all the sunny over here, and I'm finding out the entropy of the first child. Then overcast, and I'm finding out the entropy of the second child. Then I'm going to find out the entropy of the child, third child. Now, what is the weight is here? If you see this weighted average, you see this. What is the weighted average? Is nothing but the probability of that particular climate or outcome. Now, if it is sunny, is there? What is the probability of sunny in this all? How many are there? 14, right? 5, yeah, 14. This is the 14 only. Yeah, here also it is given 14. So it is 14, guys. So here, what will happen? How many are there? 1, 2, 3, 4, 5. 5 of 14 is called as a weight. What is the weight is being given? Here, what is that? 1, 2, 3, 4 is the 4 of 14 is the weight. And this one is 5. So you will see this. This is the entropy calculating. I'm calculating the entropy of sunny, entropy of overcast, and entropy of the rain. These are the childs I'm calculating. And after this, you see these entropies are multiplied with 5 by 14, which is a weight, and 4 by 14 is a weight, and 5 by 14 is a weight. Now, in this case, in the middle, there is the entropy is 0. Can you see this? Here it is 0. That is when the overcast is there, entropy is 0. Now, obviously, this will be 0. So, you are going to add this one with this one, which is 0.69. But what is our parent? 0.94. This is the outcome. Whatever the outcome is, the entropy is now when I take it out with the child, it is 0.69. Now, what is that you will be getting over here is 0.97 minus 0.69, that is 0.28 is the information gain. That is a reduce in the randomness. Okay, that is a reduce in the randomness. Now, the majorly they will be asking you to explain the entropy. They will ask you to explain the information gain. They will ask you to explain the Gini. Now, which one is the most effective one is Gini impurity. And default one is Gini impurity. What is the CART algorithm, guys? So whenever an algorithm, the sub-algorithm in the decision tree, they use the Gini impurity to calculate the impurity, then that is called as CART algorithm. What is ID3? When they use the entropy, remember that. Usually the people will get confused a lot and they don't know that they are using the CART algorithm. They will try searching for the CART. Actually, the CART is by default, it will be there. That is that using the Gini impurity. Remember that. Okay, this is all. Now, this is a very important point. How to calculate how to reduce the overfitting and the underfitting in the your overfitting and underfitting in your decision tree. There are 3 ways are there, 3 or 4 ways are there. First one is maximum length. So you can give the max depth. Max depth is what? Just now I told you. Max depth. Yeah, the distance between the root node and the leaf node is called as a max depth. So by default, there is no limit. By default, there is no limit. It will go on unless it will get the pure form of the leaves. Okay, there is no limit at all. So with that, what happens? It will go deeper and deeper and deeper, and ultimately it will be landed up in the overfitting, because our data will be very huge, guys. So you can't go ahead and give just like that. So what we will do it is, we will keep a threshold point, a point where it has to stop. Okay, then like 4. Then it will go for the 4 set of splits, and then it will stop. Okay, 4 set of nodes, and it will stop. That is one way of stopping your overfitting. The second way is giving the number of samples of the node to split. So usually what happens is, we are having a data over here. First one is, you are going to stop the, I told you over here, just now I explained you, if there is a very long, it is going on, it's going on deeper and deeper and deeper, it will be a problem. So we will put a checkpoint over there, maximum depth. This process is called as pruning. The cutting of the tree is called as pruning. Now the next one is called as sample node. Number of samples in node. So what I will keep it is, number of samples in node, I will give it as 5. Just take it. Now first, I am having the data over here is maybe around 25. Just take it. 25 points are there. After splitting over here, I got it one side, maybe 15. Next side, I got it like maybe 10. So in this, how many are there in the node? How many samples are there? 15. How many are there? 10. Now what is that? I put on the point as minimum there should be 5. If it is less than 5, it has to stop. Now is this greater than 5? Yes. Is this greater than? Yes. I will split it up. Now here what I will get it is, one is 8, other one is 7. Now in this, I got it as 1 is 4 and this I got it as 6. Now this, go to this one. How many samples are there? 8. And how many is my checkpoint? 5. So is it greater than that? Yes. So this can be further split, maybe 4 and 4. This one you take it. This will be 4 and 3. This will be 3 and 3. This one? No, this is the end. This is a leaf node. And here, these are the leaf nodes. Okay, guys, even though there is a scope of splitting it further, it will not split. Why? Because the condition is not satisfied. What is the condition? Number of samples in the node should be. Okay, that is what is called as number of samples, the minimum samples for the node. So the higher the value, we control the overfitting, but too high will be leading us to underfitting. When I'm giving a too high value, like in this case, I gave it 5. Suppose I give it over here as 20, then what will happen? This only will not come up, because this only it will stop. So it will be underfitting. So it should not be too high, the value. Make sure that it is an optimized value. Now, next way is minimum sample. Is an example. It is now the minimum sample for a terminal node. So what happens over here is, minimum sample for the terminal node is, what is a terminal node? Is nothing but a leaf node. So again, let's take it. There are around 25 and I split it over here to 15 and 10. Now I will keep it a minimum terminal node. Is equals to, I will take it as 8 or maybe around 5 or 6 I will take it. Now what will happen is after splitting over here, I should have it a minimum of 6 to consider it as a terminal node. Now if it is having 8 and 7, this is having 6 and maybe around like, or maybe 5 and 5. Now in this case, this is not considered as a terminal node. Why? Because this is not satisfying. So this is also not considered as a terminal node. We are going to stop this and this is considered as a terminal. This will stop it over here. In this case, these are considered as a terminal node. It cannot be go any further. If you split it also, you may get it 4 and 4. This get it 4 and 3. These two are not satisfying this condition. So we will not go any further of this one. We will say that this is a terminal node. Here, this is a terminal node. Here, this is a terminal. So the minimum samples should be there in the terminal node is, I kept it 6 and I got it like this. And the third one is the decision and the max depth, guys. So these are the very 3 popular mechanisms which are used for stopping up the overfitting. Okay, these are the 3 mechanisms which are used. There is a minimum sample. Next one is minimum sample for the number of samples for that, and minimum terminal node, and another one is a max depth. Okay, so these are the some of the examples we are having. Another one is maximum number of terminal nodes also. So this is about like, suppose if I'm having this, we will not use it. It is not effective of using it. Let's take it. I'm having 25 over here. Now I get the number of leaf nodes are, I'll keep it as 3. Okay. Now first one I split it over here. This I got it maybe 15 and this I got it as 10. Okay. Now this one, when I split it up, I got it maybe 3. This is the leaf node. This is a leaf node 1. Okay. Now what is left out over here? 12 will be there. Now 12 is having the randomness. Definitely it is having the further splitting chances. But here what happened? We got it like 5 and 5. So this is a leaf node and this is also a leaf node. That is a pure form. This is pure form. This is pure form. And this is, what is my total number of leaf nodes? 3. I reached the 3. Yes. Even though there is a chance of going any further, we are not going to go any further. We are going to stop it then and there itself. This is called as the number of, now this we are not going to use it. The maximum we are going to use it is more. We are going to use it is max depth. Max depth is again, which is the right value means no answer over there for the max depth. What we have to do it is we have to tune it. That's it. No other way. Now again, some cases the entropy may be the best. Some cases the Gini may be the best. We can't say that one also. So again, that is a hyperparameter. You have to tune it. There's no other option. These all are like terminal, max depth, and hyperparameter is this is the one hyperparameter, and your estimator, you can go with Gini or entropy, anything you can go with. That is again an hyperparameter. This all comes under the different hyperparameters, guys. And you have to tune them. There's no other option. You will be having a lot of hyperparameters. Once you get into the random forest, you will see the same thing. There's nothing new will be there. But only difference will be number of estimators will be coming over there. Number of estimators means how many decision trees you wanted over there. That's what you are going to get. Okay. Now this is all about your intuition and about your decision tree. I'll share you this. You can take it. Now these are the terminologies. What's the time? Yeah, we will stop it. There are some really complicated programs are there, guys, which are there with me. I will just solve them. I was just getting some problematic. I'm not getting the accurate errors. I will solve them and share it with you so that you can keep that one in your resumes. Okay. There are some very good regression problems are there and some classification problems are there. This you keep it for your resume. You do it once and then you try to keep it. There's some complicated stuff is there in that. So please keep it for yourself in your resume. And next thing is your resume should be having one text classification. Definitely you should have one text classification project. Huh? नाइबेस वाला लगा सकते हैं या एनएलपी करेंगे ना एनएलटी के एंड आरएनएन दो भी करेंगे सो यू कैन यूज बोथ ऑफ देम so one text classification definitely you should have it. Second is your image classification. One is the image classification. At least 2 projects should be from related to CNN and at least 1 to 2 projects on the NLP. And NLP you will be using in the 3 ways. One is NLTK. Second one is RNN with LSTM. That is a deep learning. These 2 are deep learnings. And next one is NIBase. NIBase is the next concept we are going to see it. There we are going to implement the NLP over here. Remember that. Okay, we are going to implement the NLP in the NIBase. We are not going to do the regression classification problem with the NIBase. That is waste. If you want, I can share you the classification problem. We have done enough classification, enough regression problems. Let's move on to the a bit advanced level. That is much better. Okay. So we are going to, and if possible, I will be doing some recommendation systems also, where you can keep it a very good recommendation system in your resume. And if time permits, we will do the your WhatsApp. You can remove it and you can do the analysis on the WhatsApp and the Twitter also. These all are, again, you know the core concepts. It is very easy to perform, guys. Once you know the core concepts, it's not a big deal. So only thing is that vectorization you have to know. Once you know that vectorization, it is very easy to do all these things. Okay. So then I will stop it over here. We will continue with region, say some different algorithms, different data sets. I will try to get it. And we will do with the NIBase also. Okay.